Methodical, confident. The centerpiece of this living room is a flawless, highly polished walnut coffee table. Its clean lines and mirrored finish anchor the entire space. But hours before arriving in this high-end environment, that exact same piece of furniture was a rugged, deeply flawed slab of raw lumber, pulled straight from a lumberyard drying rack. Looking at this layout, you can see the strict prerequisites needed to bridge the gap between raw wood and a luxury piece. We have our raw materials, a specific set of mechanical tools, and the essential safety gear required to operate them safely. The path from this rough slab to a finished table follows a strict chronological roadmap. First, we dimension the wood to its precise size. Second, we surface it until it is entirely flat. Third, we cut the joinery to assemble the pieces. And finally, we apply the rich finish. Achieving a high-end result relies entirely on this sequential process of material transformation. It requires precision at each step, rather than a shop filled with overly expensive machinery. Step 1 is dimensioning. Before making a single cut, we have to analyze the rough slab. We are looking for a section of the wood free of internal rotting, featuring a tight, aesthetically pleasing grain pattern for our tabletop. This diagram illustrates a concept called the blade curve. A table saw blade has physical thickness. If you cut directly down the center of your measurement line, the blade instantly deletes 1/8 of an inch of material. You must align the kerf entirely on the waste side. Making these initial structural cuts requires steady, forward pressure. Keeping your hands well clear of the spinning metal blade path ensures both your physical safety and a clean, burn-free edge on the thick walnut. With the rough dimensions set, we have to address the surface. As raw lumber dries, the internal tension causes the wood fibers to warp, twist, and cup. We correct this by running the wood through a surface planer or by using hand planes. The blades shear away the high points of the warped exterior, exposing the level grain underneath. To prove the surface is perfectly flat, we rely on the zero-tolerance method shown in this graphic. By laying a precision metal straightedge across the slab and shining a light behind it, we verify there are absolutely no gaps. No light shining through means the wood is flat. Squaring the edges and flattening the faces establishes a perfect geometric foundation. Without mathematically flat surfaces, every joint we cut next will inevitably fail to close tightly. We now face the main engineering challenge of the build, permanently anchoring the heavy, solid wood legs to the tabletop without using metal brackets or driving visible screws through the surface. This X-ray view shows hidden dowel joinery. Hardwood dowels bridge the gap internally, providing massive lateral strength. Clamps hold the pieces tightly, but cranking down too aggressively will physically bow the flat tabletop, ruining the perfect geometry. A secure joint requires an even coat of wood glue across the mating surfaces. When you apply moderate clamping pressure, a thin, uniform line of glue will continuously squeeze out along the entire seam. That squeeze out is your visual proof that the joint is fully sealed. At this point, you step away. The wood must remain entirely undisturbed while the chemical bond of the glue hardens and cures over the next 24 hours. Executing perfectly aligned joints is the exact dividing line between amateur crafts and generational designer-quality furniture. Before we can apply any stain, we have to prepare the surface. Sanding is highly systematic. Its purpose is to intentionally scratch the wood to remove microscopic tool marks and burns left behind by the saw blades and planers. This cross-section shows exactly why we progress sequentially through different grits of sandpaper. We start with coarse 80 grit to tear down the highest peaks, move to 120 grit to level those scratches, and finish with ultra-fine 220 grit to leave the surface uniformly smooth. Using hand tooling techniques and sanding blocks, we also go over all the sharp 90-degree corners. Breaking those hard lines creates a soft, modern edge profile that is comfortable to the touch. Look closely at this side-by-side comparison. Rushing the process and skipping strength from a coarse grit to a fine grit leaves deep, permanent circular swirl marks aggressively embedded in the wood fibers, destroying the visual appeal of the final piece. Those swirl marks might look faint on bare wood, but applying liquid stain will mercilessly magnify every single sanding imperfection left behind. This exercise in extreme patience ultimately dictates whether the final chemical finish succeeds or fails. We finally reach the finishing stage. As liquid stain makes contact with the surface, It absorbs directly into the meticulously prepped walnut fibers, reacting with the tannins in the wood to darken the color. Wiping stain onto the wood in long, even strokes allows the pigment to settle uniformly, instantly pulling the deep, complex grain patterns into sharp contrast. A successful coat requires wiping away the excess liquid within minutes. If the fluid is left to pool on the surface, it will turn sticky and obscure the wood grain entirely. Once the stain dries, a glossy protective polish is applied over the top. This clear coat cures into a hard armor layer, locking in the rich color and defending the softwood against scratches and daily wear. The finish cures, the table leaves the workshop, and the piece takes its final place in the center of the living room. By systematically correcting the warped, flawed reality of raw lumber, we have manufactured a flawless luxury centerpiece. Woodworking craftsmanship comes down to the methodical application of geometry, patience, and surface chemistry to reveal the art hidden within raw nature, and those are steps you now know how to execute.